Okay, we're going to use a tangent line approximation to estimate the value of 2.1 squared. Now, of course, if we do just a little arithmetic, for example, we could square the binomial 2 plus 0.1, and we would easily find that the result is 4.41. But if we wanted, for example, to estimate, a more complicated result, we would use the same procedure. So let's see how it works out in the case of 2.1 squared. Okay, so we could say this is the same as estimating f of 2.1 where f of x equals x squared, because the value of f of 2.1 would then be 2.1 squared. Okay? Of course, you want to go put that in your calculator, you want to just work it out on paper, you want to work it out in your head, whatever. Again, that doesn't illustrate what we want to illustrate here. So we graph the function y equals x squared. The graph will look something like this. And I'm not going to assume that the y scale is identical to the x scale, but let's just say that x equals 2 right here. Now, when x equals 2, we can easily determine that y has to equal 4. So we have the point 2,4. Now, to estimate 2.1 squared, all we're going to do is say, okay, let's do a tangent line approximation. To f of x equals x squared at the point 2,4. So the tangent line, well, let's see, slope is f prime of x at x equals 2. F prime of x equals 2x. So the slope is 4. Now, tangent line is therefore this, which is just y naught being the y value at the known point, which is 2, 4. So y naught's going to be 4. F prime of x naught is just what we calculated here. It's the slope, and I probably should have picked a different value so I wouldn't be using 4 twice, so you keep track of what 4 means, but this 4 means the original value of y. This 4 stands for the slope of the tangent line. And then that's times x minus x naught. X naught is 2. Right there is the equation by tangent line. And again, the meaning of that, if we go out to some value x here, okay, we've got the value at the tangent line, which kind of projects over to here. Okay, so this would be our value of that I've called y according to the tangent line. And we have a triangle here, one of whose sides is x minus 2, and one of whose sides I've called delta y. Now if I multiply x minus 2 times the slope, I get the rise, because the slope is the rise divided by the run. The run is x minus 2. The slope is 4. So 4 equals delta y over x minus 2, and delta y then equals 4 times x minus 2. And you want to get used to the idea that your change in y is equal to the slope times your run, times your change in x. Okay, that's the tangent line. And of course that could equal 4x minus 6. Okay, because 4 times x gives you the 4x. 4 times negative 2 is negative 8, but we add 4 to negative 8 and we don't get 6, we get 4. Where's my cloth? I think I might be smudging things worse than I started, but okay, so that is 4, and that's minus 4. Okay, so if x equals 2.1, our tangent line approximation predicts y equals 4 multiplied by 2.1 minus 4, which is 4.4. Now that's a pretty good approximation to 2.1 squared. 2.1 squared is 4.41. Now another way to look at this situation and maybe think about how it's related to the equation of the tangent line is just to calculate the change in the value of the function. So what's delta y? Of course that's y minus y naught, and it's also equal to slope times delta x, slope times run, because slope equals rise divided by run, which equals f prime of x times delta x, of course, is x minus x naught. If this is x and this is x naught, okay? In this case, delta y is the slope, which is 4, that's your f prime of x naught, and I should have said x naught here, multiplied by x minus x naught, that's x minus 2. So, to estimate 2.1 squared, your delta x, change in x, your run here, which is x minus 2, is 2.1 minus 2. If x is 2.1, then that's 0.1. So delta y equals what? Slope times delta x. Slope is 4. That's 4 times 0.1, which is 0.4. Tells us that delta y is 0.4. Well, from 4 up to 4.4 is 0.4. Tells us that the function changes over this interval, according to the tangent line, by 0.4. Now, in fact, we know the function curves up a little bit, and it changes by what? It changes from 4 at this point to 4.41 on the graph, so it changes by 0.41. Here we predicted that it changes by 0.4. And here I can write out the same thing this way. The simplest way to look at it is the change in the function, according to tangent line, is just the slope times delta x. So let's write that down once more. In general, and it's not very well drawn, but let's say here's the known point, and here's delta x. Then we have some value y naught, and we have some tangent line slope, which means that if we move over delta x units, our x value, well, will be x plus delta x. But the bottom line is that the change in the value of y is slope times delta x. And of course, if you know the function, that's f prime at x naught times delta x is just how far you got to go from x naught to get to x, which is x minus x naught. Just this picture summarizes most of what you need to know about this application or this aspect of the tangent line.